Hello, my name is Aman Dalmia, and this is a recording of the AI evaluation workshop we had a few weeks back. Due to some mistake from my side, we couldn't have the recording. So here we go again. Before that, I work as an AI engineer at Agency Fund. We are a funder doer. We fund evidence-based interventions and embed our technical and data science teams within our grantees to help them achieve cost-effective impact at scale. I have been working on using AI in the social impact space for the last 8 years. I have spent time at Wadhwani AI working on agriculture and healthcare, Avanti Fellows building open source learning products for government school students. I have also spent time building legal AI assistants at Hyperverge and AI tutors for Hyperverge Academy for underprivileged children and for the last few months, I've been building a co-pilot for nurses at Noora Health, and currently I split time between the agency fund and Art Park. And at Art Park, I work on using AI for public health, solving public health issues, and also building evaluation infrastructure. So we all know that AI is everywhere. We hear that models are constantly growing, costs are reducing, they are doing more things. But at the same time, we are seeing that a lot of AI pilots are not producing the expected impact. So, what are the reasons for that? The common challenges that we see, especially in the social impact space, is uh, failing to measure the real impact beyond demos, finding it hard to integrate AI into real workflows, building up the capacity of internal team members, and adapting the organization for this change, ensuring good data quality, and frankly, evaluations, benchmarking how these AI models perform in your context. To help with that, Agency Fund has developed this four-level evaluation framework that helps organizations understand how to perform AI evaluation in the social impact space. The four levels essentially cover different aspects of any AI product in the social impact space. The first level starts off with measuring, is the AI system performing as intended? Level 2 checks whether the overall product engages the users and retains them. Level 3 is used to measure whether the product positively impacts users' thoughts and moves them towards desired behaviors. And finally, level 4 looks at the final development outcome, like learning outcomes or farmer income, etc. For example, we will look at this case study from um, Farmer Chat, which is a product built by Digital Green, essentially which gives advice to farmers. For this product, level 1 looks like checking if the AI model gives the correct local farming advice. Level 2 looks at whether the farmers open the app on a regular basis and do they keep coming back and asking more questions. Level 3 looks at whether the farmers adopt those recommendations. And level 4 looks at whether the recommendations that they adopted finally increased yields or improved incomes. You can use this QR code to go and read the evaluation framework. This particular talk will be focused on the first level, whether the AI system performs as intended. So what do we mean by model in model evaluation? So model can mean anything from single LLM features. For example, if you want the LLM to translate a given sentence from English to Spanish, or if you want it to summarize a given conversation, or given some unstructured data like a document, if you want to extract it in a structured output, all of these are single LLM features. Essentially, you give the LLM a very concrete thing to do. It takes one input and gives one output. The second step is creating a workflow where instead of just one LLM call, you might have a sequence of LLM calls working together. For example, given a query, you might first check if it's a toxic query or if it's a harmful query that you want to reject. If not, then you might go ahead and translate the query from Spanish to English. Then you might use another LLM to then respond to the query in English. Then you might use another LLM to finally translate it back to Spanish. So in this way, you orchestrated multiple LLM calls one after the other to produce the final output. Now, agents are LLMs. LLMs, when they take actions, are what we call agents. They decide their own trajectories, they plan what should be done, they invoke tools. For example, they might conduct web search, they might query a database, they look at the result, they decide what needs to be done next, they take the action, they plan the next steps, and decide by themselves when they are done and produce the final output. We call this form of LLMs agents. And when we say model evaluation, we mean all of these. We are currently calling all of these model in model evaluation. So before we go ahead, it is important to consider or important to ask, why is model evaluation even needed? When we had this session online, then we had a lot of interesting points by the audience, and I want to share some of them here. Um, People shared that without evaluation, we can't know if AI works as intended. Different models and their versions behave differently. Even their bias and legitimacy varies. There is a risk of creating perverse incentives. The models may not be tailored to the specific use case or to the user themselves. The model may not have domain specific context. The way these models are trained and the data used to train them can all introduce biases and different failure modes. These models are often trained on high resource environments or data coming from high income countries and may not be suited well for low and middle income countries. An advice given by an AI might be technically correct, but it may not be understandable for the end user, which could be, for example, a farmer. We might have prompted the model poorly, which could be causing the model to fail. The vocabulary that is being used by the model may not be comprehensible to certain users. And at the end, AI is probabilistic and it can easily lead to hallucinations. These are all amazing points, and all of them are true. But before we move ahead, I think it can help to understand a little bit what do these AI models really work. So the way these models are trained is they are trained to predict the next word as they are speaking. What I mean by this is, suppose you take a Wikipedia page of a person, or you take a single sentence like the cat chases the rat. The way these models are trained is it would be given a partial sentence like the cat chases the, and it would be asked to predict what should be the next word. Now, as humans, we know it should be rat. But when the model begins, it has no knowledge of the world. It doesn't understand what is a cat, what is a rat, what is the relation between these. But it has a lot of these internet data. Like we have a lot of textual data on the internet where we have embedded the knowledge of the world, right? And so these models are trained so that even if it says, for example, the model might start off by saying the cat chases the school. Now that makes no sense, right? But that's how the model is at the start. It doesn't know that the cat has no reason to chase a school, for example. But when model makes this error, we give it the feedback that, hey, this is wrong, that it makes no sense, and we give it an example of what should have been the right answer. Say that it should have been the cat chases the rat. Over time, we give it hundreds and thousands and lakhs of these sentences present on the internet, which reflect our world models, right? And over time, it starts getting better. For example, in a few iterations, it might start saying the cat chases the human or the cat chases the person, which is a little bit more logical than a cat chasing a school. At least there is one animal chasing another animal, but still a cat chasing an animal hardly makes a cat chasing a person hardly makes sense. So with more feedback, with more training over time, it will become much better and eventually start saying the cat chases the rat. All to say, the way these models work is they take all of the text present on the internet and they are trained to predict the next word. They are given partial sentences and trained to predict the word that comes after it. And so now you can imagine that majority of the text on the internet is English. And so a big part of the training data used to train these models is in English, right? And so these models are inherently much better and even more efficient at English compared to other languages which are not as represented. So languages like French and English are considered high resource languages because they are represented on the internet much more than low resource languages like Marathi or Konkani, for example. Um, and they do suffer from a lot of these mistakes that everyone else has pointed out as well. And as I was saying, the models also have a knowledge cutoff. What I mean by this is that they only have access to to data until a particular date. When these models are trained, all of the data on the internet is scraped until that date, and that is used to train the model. So these models by themselves don't have access to what happened yesterday or any latest developments, right? Their knowledge is static. Also, they don't have access to your context. If you are working in a company and you want AI to work to answer queries based on your company documents or your company knowledge, unless you provide that context to the AI separately, it does not have access to it and it cannot answer it. Also, even though the model may be capable, we may not be giving it the right instructions, and I'll cover an example of that. Similarly, like AI may not be the right tool for every given task. For example, if you look at a big mathematical calculation, uh, if you ask the AI to do it, because of this nature where it predicts the next word, it is not really calculating what calculating that mathematical operation. If you give it an absurdly huge number like 55999 into 222222999, it will predict what should be the first word of the final output. It is not actually doing any computation. And so it is very, very likely that it will give you a wrong answer. And this is something that a calculator can do very, very easily, right? So I've also seen a pattern where people try to throw LLMs to every single thing out there. But if a query requires you to do a calculation, then asking the LLM to inherently do the calculation is not the right thing because it can make mistakes. Um, Now, for example, some of you may already be aware. So these models, like if you are given a task to compute this massively complicated multiplication, like 2222299 into 554443, something like that, you can you can in principle do it if you are allowed to do the multiplication steps properly. But if I asked you to give me the answer directly without thinking for even a second, if I tell you this problem and I tell you give me the answer without thinking, it is very likely that you will make a mistake as well. It is not because you cannot do multiplication, it is just that you were not given the adequate time to do the multiplication yourself to arrive at the answer. Similarly, a lot of times these models have a lot of capability as well, but we end up asking them to give the answer directly. However, if we give them time to think through step by step and arrive at the answer in a logical step-by-step manner, they end up performing way better. I have personally seen massive accuracy gains by simply giving the model more quote unquote time to think and letting it follow a step-by-step process to arrive at the answer instead of forcing it to give me the answer directly in the first go. Um, that is what I mean by us not giving it the right instructions, or us not giving it enough time to arrive at the answer. Even our instructions could be very small, they could be vague, they could be confusing, they might be conflicting. We might say something at the start of a prompt, but say something completely different at the end. It is similar to the problems of communicating with another human. If we are not clear, if we are not detailed enough, it is likely that they will follow some other interpretation that we didn't have in mind, right? So our instructions could be wrong. And even if the accuracy of AI is as good as we need it to be, it is possible that it may be just too slow. It's possible that given a user query and given adequate time, a model could research all over the internet and come back with the right answer in an hour. But maybe for your context, that might be too slow. And that is also a failure mode. And these models could potentially be very costly as well, depending on the model that you are using, how you are using it. And so, for a model to succeed, it has to also be cost effective based on whatever your definition of cost effective means. Some other questions that were asked during the session was whether training on your own model on your own data reduces these problems. Um, but that is not, number one, that is not trivial to begin with. Even if you get the right data, getting it to work, hosting your model, deploying it in a way to that makes sure that the speed of talking to that model is fast, is a very hard problem. A big reason that a lot of people end up finally using off-the-shelf models like OpenAI, Claude, or Gemini is because they work very well out of the box in terms of speed and cost. And even with the right prompt, they can get to a right answer for your context, right? But in some cases it may not. Like if your use case requires a low resource language, or it's a very niche domain, um, it may not be possible to get these models work. But I would not start with that assumption. Of course, it's not a default that they will work as easily, but that doesn't mean that there aren't ways to get them to work, right? So not I would not suggest jumping to training your own models, even if you can, because hosting it, maintaining it, continuously improving it is all a challenge. Like tomorrow, OpenAI might come up with a much better model with a bigger data set, or Claude might come up with a new capability, and you can switch it for hardly any cost, right? Versus if you maintain your own model, you might spend months doing that, and the next update by any of these providers might completely render all of your effort useless, right? And that risk is real. um, um, yeah, but it's again not to say that it's not possible to do it. If you have the technical capability and none of the existing models are close to working for your use case, it may be worth doing it. Um, but the problem of evaluating your AI model is still true. Even if you're maintaining your own model, you still need to evaluate if that trained model works well. Um, and then the next point of our discussion was, why has model evaluation been hard for people? Again, a lot of interesting responses by people. One of them said that it was very hard to operationalize AI evaluation as an ongoing task. The responsibility often fell on CTOs who are overly overloaded, and there's no clear definition of when evaluation can be considered done, and there is even no practical checklist or a tool or asset to get started. It's often difficult to determine what good looks like. Um, when Once you start building, they find it hard to slow down and ask these hard questions. Often people struggle with evaluating non-deterministic outputs, which are often the case with these generative models now. Even two same prompts may produce two different outputs with the same model, making the evaluation results unreliable. And once the failure modes are identified, some of them don't know how to, it's not clear how to act on them quickly and make fixes. Um, And again, all of these super helpful. And the only thing I can add is that we don't need to look for perfection or waiting for the evaluation to be done. The key idea is iteration. We need to start small, build a small data set, evaluate how whatever our current system is works on that data set, find the failure cases, identify why those failures are happening, and keep improving our prompts or our AI pipeline. And as we deploy it out, we gather more edge cases, newer edge cases, bring it back to our evaluation data set, keep growing it, and keep evaluating and improving step by step. Iteration really is the key. Um, and another question was whether evaluation is needed at all if one restricts AI to their own data set. For example, using a RAG setup, right? Now, like if someone can give their own documents, they are asking if evaluation is still needed. If we are restricting AI to those documents only. Now, this assumes a lot of things. Firstly, we are assuming that the model will stay restricted to that context. We have given it some context, we have given it a few documents, but we are assuming that the model will only stay restricted within that context. That needs to be validated. We cannot assume it. Secondly, the right answer for a given query may be somewhere hidden inside a 1,000-page PDF. And it is possible that the model may not find it, may not retrieve it. Even if the model retrieves a particular paragraph from that PDF that is relevant, it may not perform the right reasoning required to arrive at the right answer. It may have the right source, it may find the right paragraph, but it may reason itself to a wrong answer. So every step needs validation. Yes, using your own documents uh, reduces the probability that it will make a mistake, but uh, there are still there is still a big scope for error. So evaluation doesn't go away. Um, Okay, next we'll talk about what needs to be evaluated. So typically, AI pipeline involves multiple components. From receiving the user's input, if it is an audio input, you might convert the speech to text. You may put some guardrails like checking for harmful inputs that you don't want to respond to. You may translate the input from, say, Marathi to English, because Marathi is a low resource language and the performance of AI models on low resource languages are not as great. Now, that is the pre-processing step. Then you may inject some context into the model, like, for example, the previous conversation history or the prompt, and you may use a particular knowledge base that you are injecting in. Similarly, you may have a post-processing step. Like after the model's output, you may convert that text to speech. You may translate it from English to Marathi back. You may put an output guardrail for preventing any harmful outputs to go back to the user. This and there are many more components as you move towards agentic systems like calling tools and importing things like skills and whatnot. So everything here needs to be evaluated. Now let's talk about how to begin evaluating, right? So the first reflection question here is, how would you judge a human um, for when they do the same task, right? And this brought about a lot of questions. For example, someone shared that for an Aadhaar self-service kiosk, they used historical throughput data from human operators at a center as the benchmark, like number of beneficiaries served, escalation rates, but not really quality and satisfaction data, because that was not available in the government sector. Someone else said that in consulting, she evaluated humans by checking whether they followed the right process and logical framework and not just the final answer. She felt that if the process is right, the answer will likely be in the right zone. Similarly, another person shared that they used the analogy of customer support call recordings by randomly sampling some call recordings and checking against some predefined set of metrics like accuracy, usefulness, handling difficult situations diplomatically. Um, someone else shared that for assessing a human communicating agricultural information to a low literate rural woman farmer, she would actually interview the farmer about what they understood and not really the trainer. For her, the user experience is what matters most and not the trainer's self assessment. Um, Similarly, so she asked if the human agent is even the right benchmark. Sometimes the end users may not be happy with humans, right? And someone else raised the question of how to know if human performance is good in the first place. Sometimes it may not be right to judge the AI against a single human's response as well. Different kinds of users may need different levels of information, like a farmer versus a field extension worker versus an agriculture expert. Sometimes AI can even exceed a single human on what it can do in terms of precision, understanding, understandability, or feasibility. Um, but another perspective is that we actually do screen humans, right? Before we trust them, we move them through an interview process, we do background check, we do reference checks. Currently, we don't have any such process for evaluating AI, right? And I, I think that's the key question here, that it's not that we haven't been evaluating humans, we have, just in a different way. And now we need to put in place some kind of a interview process for AI before we put them out in the field, right? We hire, we go put humans through an interview process before we put them out into the field. Similarly, we cannot try AI by starting off by putting it out in the field. We have to first interview the AI, check if it matches some kind of a bar, and then we put it out. A human, it's not that a human never makes mistakes, they do. Similarly, the AI will also not be flawless all the time, but it still needs to pass a bar before we can deploy it. um, Someone else asked that can we ever be confident in deploying AI, right? Because there could still be hallucination, and how can we convince any client that the model will behave consistently and it can still give out stupid answers, even though with humans at least. The mistakes can come from lack of knowledge, but it's not completely random, right? And the idea there is that again, we cannot ever be like 100% confident, right? If we do that, then we are waiting for perfection. In most cases, it should be possible to do some kind of iterative deployment, and uh, in other cases, we should be able to hand off to humans when we feel that the AI is not adequate. We can, and again, evaluations help us inform that, right? We start with a small golden data set which covers our core use cases, and we have different kind levels of use cases as well, right? Where some use cases might be or some queries might be super sensitive and we need AI to be almost perfect in those queries, but for other queries we can be more lenient, right? So there's a gradation there, and we can set our own thresholds for how good we need the model to be before we can deploy, but we can use a human in the loop as a fallback for cases where the model is not very confident. And there are different ways for measuring confidence of a model, and it is true that there's no standard way, a standard or reliable way to measure models confidence at this point which can be fully trusted. But the idea is that we can progressively deploy the model from low risk to higher risk settings as the accuracy of it keeps improving over time, as the evaluation data set grows, as it reflects more realistic queries, more realistic responses, and eventually incrementally the performance improves. Um, Now, another important question for you to ask is that if a human can do the task well, why do you need AI at all? The idea is not here to unnecessarily say that you don't need AI. The idea is just to figure out what is the core use case that you have of AI. Do you need AI because you cannot scale without it? Is it because the cost of a human is too high? What exactly is the value proposition that AI is bringing to you. Sometimes in the AI high praise, it can become a matter of just injecting AI without really thinking where is it actually adding value. And this question is just a way for you to step back and think, why really do you need AI? Now, to begin evaluation, we need to define firstly rubrics. These are basically the characteristics that you want your AI solution to exhibit. For example, one rubric could be accuracy. The response, you want the response to address a specific user's query instead of giving some kind of a generic answer. And for example, if it's a health query, then you want it to be medically accurate. You also want the response to be safe. In a medical context, it might mean that you don't want AI to recommend any particular medication, or you don't want it to diagnose. Typically, you will be able to classify your rubrics in three broad buckets. One is, does it work? Quality. Then second is, how much does it cost? And third is, how long does it take? Whatever rubrics you can think of fall under these three buckets. Let's take one example from Noura Health. It's a nonprofit that helps caregivers uh, through its WhatsApp messaging service. Caregivers can ask questions, and there are nurses who sit on the back, and they respond to those caregivers with their queries. We have built an AI copilot for these nurses to help improve their turnaround time. One part of that copilot looks like this, where for a given query, we have to identify if it's an emergency or not. If it's an emergency, we simply raise an alert. Otherwise, we use the knowledge base to respond to that query. Now, there were three different choices or slash trade-offs that we had to make. Um, the first one was, we first ask for emergency detection, and if it's not an emergency, only then we trigger the response generation. Because if it's an emergency, we don't really need to generate the response now. In this case, the cost was good, the quality was good, but the time was not good, because we are using a strong model, and then after that generating one more response using another model. One solution that we tried was shifting the stronger model to a smaller model for emergency detection, so that that step can be faster. However, we found that in this case, quality suffered. Finally, we tried another variant where we trigger AI for both of them in parallel. So once a query comes, we also assess whether it's an emergency or not, and we generate a response as well. If it's an emergency, we just discard the response generation output. But if it's not an emergency, we have this response ready. So in this case, time is saved, quality is good, but the cost suffers. Now, given where the nonprofit was at, out of these three trade-offs, it was able to do a trade-off on cost because we had some credits, and at this time improving on quality and time was not an option, and cost can be solved for with time. Next, you need to define the metrics that are required to compute or measure those rubrics that you defined earlier. One example is using statistical measures. For example, suppose if you have predicted AI response and you have a reference AI response, a very bad but very simple metric is to simply check how many characters are exactly the same. It's a very bad metric, but it illustrates the point that these metrics, these measures are very fast, very cheap, doesn't cost you anything really, but they are often not very accurate. Another option is to use humans as a judge. Here, what we call vibe checks is essentially you looking at a few outputs randomly and saying, yeah, it looks fine, or it doesn't. Or you might have a few experts sitting in a room and just rating each response between 1 to 5. Or the experts might leave comments as like qualitative feedback on the quality of the responses. And as you can see, you don't they are like very accurate often because these are humans and experts giving these reviews. Sometimes it may not be fully accurate, but it is often the most accurate option out there. At a low scale, it's super fast. You can just get like 10 experts in a room. In 30 minutes, you can get a bunch of responses. But it is often not possible to do this at scale or costly at scale because of humans essentially being slower than machines, or not being able to get the time of these experts, or these experts being very costly. Uh, there are many reasons why human as a judge does not often scale. Uh, and the final option is using model as a judge, or what we call LLM as a judge. Here, we typically use a stronger LLM as a judge to evaluate the response of a weaker model. The typical question that is asked here is, if we have a stronger model, why will we not directly use that on production, right? And the problem is that the stronger model is often also costlier and is slower. So what you typically do is you try to find the smallest model that can perform almost as well, and you deploy that model, which is more cost effective and faster. And you use a bigger model to evaluate the response of the smaller model, because when you are evaluating, you can take time. You can choose which ones to evaluate at. You don't need to evaluate every sample. And so making this makes it feasible. But you need to also benchmark this stronger judge model against some kind of human expert data as well, to make sure that this judge is aligned with the human experts. And if it is not, you need to iterate on getting the judge to become trustworthy before you can start using it, and trusting its outputs. So it can be very accurate, it can be reasonably fast because it's just an API or an LLM judge running in the background, but it is often not very cheap. There are ways to make it cheaper by fine-tuning a smaller judge model, but often that takes effort. Um, Now, one question that comes up that was shared for this section was, how to use a model as a judge when the system being judged is a RAG model with a proprietary database that the judge does not have access to. Um, yeah. So in this case, what earlier used to happen was you would have the AI response, and you have the you typically prepare some kind of a golden response by an expert, like, hey, this is a good ideal response, and you compare that with the AI response. Now you can compare it across, like when you are comparing it, you can just look at the factual content of the message, irrespective of whether it came from a database or not. So whether it came from a RAG pipeline or it came from an LLM directly, what you are comparing essentially finally is the end response. It doesn't need to have access to the database. It just needs to match the golden response, right? So what typically used to happen was have a golden response, have AI response, and make sure that the AI response matches the golden response. But when you do this in practice, you realize that it is harder. It is much harder to identify what exactly needs to be matched between the golden response and the AI response. If something is not present, is it significant enough to be considered missing, or is it insignificant? It's hard to define that. And so what people typically do now is move to more of a rubric based evaluation. Here, instead of an ideal response, we have certain rubrics, like the rubrics that we define potentially, but you can say you can ask very concrete things. For example, if there is a query, like a health query, you can put specific line items like, hey, it should not suggest any medication. Or if it's an emergency, you can say, hey, does the message clearly say that it is an emergency, and does it ask the user to call a helpline? And it can also be a specific line item that, hey, is the message empathetic? Is it acknowledging the user's situation? So each of these items can be individual checks that we place, and it can be like a very simple binary check. Is this happening or is this not happening? Is the message recommending medication or not recommending medication? Is the message calling it out as an emergency or not? So what is typically done is, instead of giving an ideal response, we mention what should a good response have. And for each line item, we measure it as 0 or 1. Um, And so, for example, if you mention five such line items and the answer satisfies three of them, then you can score the response as 3 out of 5 in that sense. So, as a leader, what matters to you is ensuring that your team has high velocity and not just high speed. And the way you can do that is by asking the right questions. For example, is this even the right thing to build? Is the core challenge 100% AI accuracy? What if you achieved it? Sometimes you can be so blinded by wanting to achieve the AI accuracy that you can forget about the following problems. For example, adoption, building your product in such a way that the users actually like it, the users understand what is being done, users get benefit out of it, right? So try to think ahead. What if the AI system worked? Is that your biggest problem? Was that your biggest problem? Was that the only bottleneck? Sometimes people end up trying very complicated approaches for getting their AI systems to work. You can ask them, like, have we tested the simpler approaches exhaustively? Sometimes we might be evaluating our system on a data set that is not even representative of our users. Right. And sometimes your teams will have trade-offs between whether to pursue 5% accuracy improvement or a 10x cost reduction. In that case, you need to set that direction. What is better? Sometimes you don't need to build everything by yourself. You just need to maybe buy a tool. Sometimes you don't need to build anything and you just need to wait out for the next model update. So you need to help provide clarity to your team and help them balance what matters across the different rubrics that you care about. This is the way that you can truly impact your AI team and the AI development without feeling lost. Um, and what it typically looks like is you create some kind of a what we call the golden set. So it contains expected user interactions, and it could be ideal responses to them, or it could be rubrics that expect rubric based expectations, as I shared before. It should contain ideally out of scope requests that the model should ignore. This tests whether the model does ignore before you put it out. It should also contain some, even if it's a few, maybe just 5 or 10 malicious or unsafe requests, to make sure that the model does not reply to them or replies to them in a safe manner. Um, Now, why is this golden data set needed? So that when you are making changes to your AI pipeline, you can see the performance or you can see the impact of each change. Right, so you compute for each for on this data set, you compute the metrics that we talk about, right? And for every change you can look at how your metrics get impacted over time. As you keep making more changes, keep improving your data set, you can also keep a track of your performance over time. And when you make changes, it will help you prevent any regressions. So you have certain metrics, you need to make sure that your metrics don't go down when you make any changes. Having this golden data set will help you make sure of that. Otherwise, you might put out an update that solves a current problem, but it introduces a problem that you had solved 2 weeks before, right? You don't want to do that. Um, Now, how can you create this golden data set? If you already have, like, say, a non-AI product and you have some interactions already going on between the user and the humans, you can create those past interactions to source this golden data set. Or if it's a completely new product, you can use your understanding of how the users are going to use the product, your understanding of the users, to generate this data set. You can imagine that, hey, if a user asks this, you can run your AI through it, and then you can have the expert. Sorry, you can imagine that these are the queries that your user may ask, and then you can have the expert come up with the right answers to those queries. In this case, what we strongly recommend is to avoid using AI to prepare the ideal responses by the experts, because and at the end, humans are lazy, and we if we are given a response to edit, we will make some minor edits to them, but often we may not completely rethink all the mistakes with that. So it's better to just ask them to write it from scratch, at least at the start, because this data set will be the core of what you build. And if the ideal responses that you are trying to mimic, they themselves are wrong, then everything else that you build on top of it will be wrong, right? So this is crucial enough for you to spend that time by the experts sourcing or creating those ideal responses or the expectations from the ideal responses from scratch using their own knowledge. We really recommend this notion of minimum viable evaluation. We don't want you to aim for perfection. You can start with a 30 to 50 item golden set where you just have, say, 30 or 50 queries or 100 queries that represent diversity of use cases, diversity of user interactions, and you can have the expert uh, produce outputs of these 50 or 100 rows, right? And as we said, it should ideally cover some kind of a guardrail metric. It should trigger some kind of out of scope responses, and it should be representative of what your users are actually going to ask. And then it's a matter of testing, analyzing, and iterating. You test your current AI pipeline on this golden data set, look at the metrics, identify where it's failing, go back, understand why it's failing. It could be because there is a mistake in the prompt. It could be that it's answering something which it should not, or it is not retrieving the right knowledge from the knowledge base. There could be a bunch of reasons to that it is not able to give the right answer, right? And then you, based on your analysis, you test your assumptions, you test your hypothesis, and again evaluate, again test, again analyze, and keep iterating this way, right? And once you are done, once you have reached a certain level of performance where you think that the model is working well now, you launch it, right? But even after launching, your testing, analyzing, and iterating doesn't stop. So this is what we call offline versus online evaluation. Offline evaluations are when you test your AI system in a lab setting on your golden data set that we spoke to you about. This means like identifying and fixing any obvious issues um, before you put it on production. However, you don't want to spend a lot of time doing that before putting it out there, because you might essentially just be guessing what real user interactions look like, versus when you put it out there, your users may use it in a completely different way, right? So you want to strike the right balance between fixing obvious issues, but also putting it out there so that you can start working on the real user frustrations. Online evaluation is when you evaluate your AI system on real user queries after launch. What this helps with is understanding issues real time as they are occurring, on real user frustrations, but it can be very expensive. It can be expensive, and it can be hard to do in the right way as well. There is no set recipe on what is the perfect and obvious way of doing it. Um, and our goal, typically, what we recommend people and what we support our grantees with is creating this pipeline, creating this loop of developing a golden data, of deciding a rubric, metrics, developing a golden data set, running automated evals, refining and iterating, deploying, then looking at your AI responses as it is operating on real user queries, monitoring them, performing online evaluation on those queries, identifying what are the issues, putting those issues back to your golden set, and running the iteration process again. Typically, an online evaluation process could look like running an LLM judge on each and every query, and then looking at the queries where the LLM judge is failing. It could be that you can sample a certain amount of queries. For example, if the response length is too short or if it is too long, you can run the LLM judges only on those queries. You can use a lightweight small language model to perform some categorization of queries, and you can look at only certain categories of queries which you think the model could be performing worse at because it was not part of your initial golden set. So there are many ways of how you sample your production queries, which ones to evaluate, how to evaluate, looking at each of them, identifying the errors, bringing it back to your offline golden set, and continuing the process of iteration. Um, and these are a lot of resources that cover a lot of details of setting up this loop. And I don't want to repeat here what is beautifully being laid out in these blog posts. And there are many, many more resources out there. And a lot of things depend on the particular context that you are in. But here we want to talk about the overall framework, because this session is aimed at targeting leaders, and you are most likely not going to dive into the specific implementation details, and you can maybe pass this on to your engineering teams who may already know a lot of these things. um, we are in the process of creating a new version of the 4-level evaluation framework. So if you are interested to be notified about the new version when it's released, do sign up to this form. And yeah, thank you so much for staying with me and listening to me and spending your time with me. You can reach out to me if I can be of any help. This is my LinkedIn profile, and here's my email. Thank you so much.